Hey gang, so if you are still struggling a little bit, or maybe you've missed a couple of classes and you're like, oh my gosh, what in the world are they doing? Let's just go back over some basics of factoring. So first off, your teachers put this up there, or maybe you're in my class here like, Mrs. Dean, I am so lost. What is factoring? So let's take a scenario and let's review what factoring is. So in the past, I gave you x plus 2 times 3x minus 1. And we would do this. We would take it and we would say, okay, let's hippity-hoppity distributive property. X times 3x. And you would say, oh, Mrs. Dean, that's 3x squared. And then you would do x times negative 1. That's negative 1x. And then we would do 2 across the bottom. 2 times 3. And we would say that's 6x. And we would say it's a positive 6x. And then we do 2 times negative 1, and we'd say that's negative 2. We would every time draw the line, and we would add it up. This would be 3x squared. We would do 6 minus 1. That would be a positive 5x. And then we would say that's negative 2. So here's what factoring is. What if I didn't give you this? What if I just gave you this, and I said, hey, what was this before it was, what was this before we multiplied it? In other words, I'm wanting to know, what was it in parentheses before it became this? I want to know, what was it here when it was x plus 2 times 3x minus 1? What was this up here? So I'm giving you this, the multiplied version, and I want to know what was it in factored form. So think of it like this. If I give you the number 12, what are the factors of 12? Well, you could say it's 3 times 4. These are the factors of 12, 3 times 4. What are the factors of 3x squared plus 5x minus 2? They are x plus 2 times 3x minus 1. These are the factors. That's what you're doing. You are factoring this. Only it just looks a whole lot different because it's not just numbers. So when I give you this and I ask you to factor it, I want something times something. So that's what we are doing. I want to know, what are the factors of this? What is something times something? You have to figure out what goes in here. It's real easy to get the first term. Remember the first this times this, the first two terms? Because the first two terms is this times this. When I go from here to here, the first term, it's x squared. Isn't it real easy to see, well, that's x times x. So you know here, and these are both positives. So that means everything here has to be positive. But what's not so easy to see is what goes here. And so what we typically do is we say, okay, this is a square, right? X squared. Look what I'm going to draw. What is that? It's a square. X squared. I'm drawing a square. Okay, that's where the square comes in. Now, here's the way the rule works. You take x squared, it goes in the first square of the box. The 6 goes in the bottom box. And that's the first rule of the box or the square. What goes in these two corners here is you are going to make an X, kind of like X marks the spot, and we are going to make what's called a rainbow. When you make the rainbow, you take the number right here in the front, which in this case just happens to be a 1, and you make a rainbow from the 1 all the way to the other number. And you multiply, I'm going to write the word multiply, across the rainbow. 1 times 6 is 6. And so you put a 6 at the top. You add to get the 5. And that goes at the bottom. So you add to get the bottom and you multiply to get the top. Multiply up, add down. Okay, I gotta get a drink. I got this big jug of water I'm trying to drink. What I want to do with this 6 is I want to do all the factors of 6. So this is a real easy trick. Now, I know you know the multiples, the factors of 6, but this is just an amazing trick that I want to show you that is super helpful. I want you to put 6 into your calculator, and I want you to divide it by x. Okay, 6 divided by x. Now, I'm going to zoom in a little bit on this just to show you. I want you to go to second table and look at this. 1 times 6 is 6. 2 times 3 is 6. 3 times 2 is 6. And then they start repeating, right? 6 times 1. These are the factors of 6. So I'm going to come over here. I'm going to do 1 times 6, 2 times 3. And then it starts repeating over here because I'm back at 3. These are my factors. What I want to look at is the factors that add to 5 but multiply to give me 6. Which of these add to 5? You know what? The ones that add to 5 are right here, 2 and 3. 2 plus 3 give me 5, but they multiply to give me 6. So here I'm going to put 2 and 3. All right. So now I know my x is complete. That means that these values right here are going to go in my box. So I'm going to put, now, before I forget, my box is not complete. My box has to have variables in it. So when you fill it out, you put x squared and you put 6. But in these two sides, whatever the variable is right here, you have to put it right there as well. So you have to have x, x, and x. And then this is the only one without a variable. Okay, so we're putting a 2 and a 3. It does not matter where you put the 2 and the 3. You can put 2 here, 3 here. You can put 2 here, 3 here. However you want to do it, it doesn't matter. I'm going to put 2 here and 3 here. Now my square is complete. My box has values all the way across. Now I just have to finish the box. What I want to think about, I was looking to see if I had a little piece of paper. I don't. Okay, I'm going to think about my box as a bunch of little boxes. I want to think about this as the area. Okay? To get the area of x squared, I'm going to have to say if this was x, what did I multiply this by? X times what here? X times what would give me x squared? Well, if this side right here was x, then this side right here would also need to be x. X times x would give me an area of x squared. Okay, well again, if this side right here is still x, what would this side right here have to be to get 3x on the inside? This side would have to be a positive 3. X times 3 would give me 3x. X times what right here would give me 2x. A positive 2. 2 times x would give me 2x. 2 times 3 would give me 6. Okay, now my square is actually complete. Here's what I know. The box factored to be x plus 3. So over here, I'm going to put x plus 3. And over here, I've got x plus 2. X plus 2. This is my factor. This means that x squared plus 5x plus 6 factored to be x plus 3 times x plus 2. How do I check to make sure I got it right? Because that is the beautiful thing about quadratics. I'm going to put this in, and I'm going to say x squared plus 5x plus 6. Down below, I'm going to put what I got, which is parenthesis x plus 3 times x plus 2. I'm going to graph it. If I graphed it right, the graphs should be right on top of each other. There's the blue one. Looky there, did you see it graph right on top of it? Now let me show you what it would look like if I had not graphed it right. Let me change this to like a subtraction. Okay, so there's the first one. There's the other one. If I had graphed it incorrectly, in other words, if I had done this wrong right there, it would not have graphed right on top of each other. Now, I did graph it right, so that one graphed correctly. So I want to do another one. We're just getting started, just getting warmed up, just trying to make sure everybody's on the same page with our factoring. Okay, I'm going to go to y equals. Let me clear this out because we're going to do another one. So here we go. X squared minus 9x plus 14. The question on the table is, can you factor this? So here we go. If I'm going to factor it, I want to draw the square box, and I want to try and factor this. So I'm going to say, okay, well, let's see. I'm going to go ahead and start and say, this is x squared, so I know this is going to be x and x. Oh, these are not all positive, so I don't know what's going to happen here. I do know that this one's negative, this one's positive. In order to multiply to get two positives, these are probably going to both be negative, because I'm going to have to do a negative times a negative to get a positive. But I'm not going to go there yet, because you might not know that. That might be something that you don't quite comprehend. That's okay. So what I do know, though, is that I need to make an X, and I need to make a rainbow. So I need to put a 1 right here, and I need to say 1 times 14, and fill in this. I'm going to do 14, and I need to multiply here to get negative 9. Okay, we add, and we multiply. Multiply up, add down. Now I'm going to go ahead and fill in my box. X squared goes here, 14 goes here, the first and the last. On the two sides, I need to make sure I put my x's. X, 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 14. I'm good there. I'm going to come over here and do my factors of 14. Now 14 is pretty easy, so I'm going to go ahead and just say, well, that's 1 times 14 and 2 times 7, and there's not any more, so I'm just going to do that. Okay, I'm going to let you look at that for a second. We want it to add up to 9. So we can figure out what it's going to be. All right, so hopefully you're thinking 7 and 2. How can I get 7 and 2 to add up to negative 9? Well, they're both going to have to be negative. Negative 2 and negative 7 add up to negative 9, and they multiply to give me a positive 14. So I'm going to put negative 2 and negative 7. Those add to give me negative 9 and multiply to give me 14. Okay, so I'm going to take these two values and put them down here. And again, it does not matter where you put them. I'm going to put the negative 2 at the bottom and the negative 7 at the top. Okay, so now remember, we're going to cover this up. And what we're going to do is say, how do I get that first square? X squared would be x times x. Now to get 7 right here, x times what would give me negative 7? That would be negative 7. Okay. X times what would give me negative 2? Negative 2. Let's check. Negative 2 times negative 7 would be 14. Okay, so let's double check all our multiplying. X times x is x squared. X times negative 7 is negative 7x. Negative 2 times negative 7 is positive 14. Negative 2 times x is negative x, 2x. Okay, so that all worked. So what do we get? X minus 7 on top, x minus 2 on bottom. Now, something you might be asking yourself is, does this matter? Could I say x minus 2 times x minus 7? Could I swap those? Absolutely. Because let me ask you this. Is 4 times 3, does that equal 12? Yes, it does. Does 3 times 4 still equal 12? Yes, it does. It doesn't matter which side the 4 and the 3 is on, does it? You know what? It doesn't matter which one's on which side. All right, let's check it. Here we go. Y equals, let's go to the top. X squared minus 9x plus 14. And then let's do x minus 7. And if you're just watching me do this, absolutely. Okay, here it comes. You ready? You ready? Here we go. Blue. Cross your fingers. And it turned red. So we did it right. Yay! Okay, so Sorry, there's like a little bird chirping noise in my room. I don't know what that is. All right, here we go. Stepping it up. This one's a little harder, people. This one's a little harder. Here we go. I want to factor it. If I want to factor it, that means I want to know what times what. If I want to know what times what, then I need to draw a box. Okay. So I'm going to go ahead and do 2x squared, negative 45. I'm going to put the x in the x. Woo, okay, it's going to be a big number. 2 times negative 45. I might have to break out my break out my calculator for this one. All right, here we go. 2 times 45 is going to be negative 90. Well, it'll be negative 90. I didn't put the negative on there, but it will be. So we're going to have negative 90 on the top. We're multiplying up, and what are we doing on the bottom? We are adding. And so, what's it going to be in the middle? There's no number. There's a 1. Numbers, okay, 90's big, y'all. This is where my trick is going to come in handy. So I'm going to zoom in on that. Here's my trick. Y equals, clear all this out. Grab your calculator, Desmos, whatever you want to use. 90 divided by x. Second table. Here we go. 1 times 90. 2 times 45. 3 times 30. 4 times 22.5. That's not going to work. But 5 times 18. 6 times 15. 7 times that doesn't work. 9 times 10. There it is. And then it repeats 10 times 9. 10 times 9 we already have because we got 9 times 10. So we're already going back up, and so we're good. But do you see how nice that is to see all those? Isn't that nice? Okay, I got really whoppy jawed there, y'all. Okay, so I need the factors to add up to negative 1. The only ones that are close enough are 9 and 10. If I want to get a negative 1, I would, y'all, I got really close there. I would have to use 9 and negative 10. So negative 10 and a positive 9. Negative 10 plus 9 would give me negative 1 when you add them. And when you multiply, you'd get a negative 9. 90. I'm going to take these and I'm going to plug them in down here. Okay, so I'm going to put a negative 10 and a positive 9. Okay, we got to factor this now. Now, this one's just a little bit different. When I look at this top row, because there's 2 coefficients, I need to make sure that 2 and 9 don't have anything in common. And they don't. There's no GCF. Remember, the greatest common factor. So I'm still just really looking at what do I need to do here. So in order to get this number here, I need to think about, well, how do I get, what do I multiply here? So 9 and 2 don't have anything in common, right? So I'm going to put, I know it's going to be x and x, but I have to think about, I have to get a 2x squared. But if I put a 2 right here, like if I put 2, in fact, I'm just going to kind of write it out here. If I were to put a 2 right here, 2 times what would give me 9? And there's not anything. So that's why I really don't want the 2 here. I want to put the 2 here. And then I can say x times what would give me 9? And I can say 9. 9 times x is 9x. And so you kind of see why this right here, you can't put the 2 here because 9 times x is 9. 2 times x is 2x squared. So this would be a positive right here. Does this kind of make sense as you look at that? Now when I move my hand, let's see if we can do the bottom. So let's focus here. 2 times what here would give me negative 10? 2 times negative 5, right? So if I put a negative 5 right here, 2 times negative 5 would give me negative 10. Now let's check. -5 times 9 would give me -45, and it worked. So what are these factors? 2x plus 9 and x minus 5. Okay, let's check it. So y equals, you can just watch, 2x squared minus 1x minus 45. 2x plus 9, x minus 5. Oh, let's graph it. There's 1. Oh, it went right over it. Bam, done. Okay, as you're beginning to get the hang of this, if you feel like you've got it, try this one. I encourage you, if you think you've got it, pause your video, see if you can do this whole one. I will do this one, or at least mute your video if you haven't already got me muted. See if you can do it. All right, assuming you've already got it, here we go. I'm going to put 3m squared, and I'm going to put 15. I'm going to draw this. I'm going to make the rainbow. I'm going to do second quit. I'm going to do 3 times 15, which is going to be 45. I'm going to do the factors of 45 that add up to -14. To get the factors of 45, I'm going to go to y equals. I'm going to do 45 divided by x and go to the table. So I'm going to do 1 times 45. I'm going to see that 2 doesn't work, but I'm going to do 3 times 15. And then I'm going to do 5 times 9. And that's going to be all of them because after that, 9 times 5 is the next one. I need to add up to a -14. The only way to get there is going to be 9 times 5. It's -14, so they're going to both have to be negative, -5 and -9. And when I multiply, it will give me a positive 45. So -5m and -9m. When I look at the top, I'm going to notice that to get a 3m here, I'm going to need an m and an m. But the thing that I'm noticing is that if I put a 3 here, I need to multiply this 9 right here and get a -9 up here. But I also notice here that I'm going to need to get a 3 right here. And so I'm kind of thinking that I need to put a 3 here because 3 times what would give me 9? And I'm noticing that I could put a -3 right here because -3 times 3 would give me -9. 3 times m would give me 3m squared. So I'm thinking right here that the GCF of 3 and 9 is 3. And that works right here. I can factor out 3m. And this would be 3m times m is 3m squared. 3m times 3 would give me -9m. So I feel like that looks good up there. Now I'm going to look at just this one right here. M times what would give me -5m? And I would need a -5 out here. -3 times -5 would give me +15. Okay, so that works there. So that means I've got m minus 3, 3m minus 5, and I'm going to tell you right now that that works. And that is your factors on that one. All right. I'm going to do one more, but if you feel like you've got it, go ahead and go to the worksheet or whatever it is we might be doing today. Here we go. This one, I'm going to draw my box. Here we go. 3x squared and 20. We're going to make the rainbow. 3 times 20. Factors of 60 that add up to 16. To get those factors of 60, we're going to go to our calculator. We're going to go to y equals, and we're going to do 60 divided by x. We're going to go to second table and get those factors of 60. So we're going to do 1 times 60, 2 times 30, 3 times 20, 4 times 15, 5 times 12, 6 times 10, and then the next one you see down here is 10 times 6, and since that's repeating, we don't need any more. I need to add up to 16. The only way to get to 16 is 6 and 10. And they're both going to be positive. So we're going to have 6 and 10. So I'm going to put 6x and 10x. All right. I know that it's going to be x and x. So I'm going to start here. 3 and 10 have nothing in common, which means I'm not going to put anything over here because they don't have anything in common on this row. That means my 3 is going to have to go up here. 3x times x. X times 10 would get that 10 there. So this top is pretty easy because they don't have anything in common. And this would be a positive. Then I'm going to turn it and I'm going to go this way. 3 times what would give me 6? 3 times 2 would give me 6. And 2 times 10 would give me 20. So that means 3x plus 10 and then x plus 2. And again, I'll let you know that works. You can plug them both into your calculator and see if they work. All right, I hope that helped you on those. That was about 30 minutes of review of factoring.